Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 8, Section 3 with you, all about solving right triangles. And we've talked a little bit about right triangles and solving them already, and we've talked about some of the trig functions that we've used and how they basically can help us with finding some things out about triangles, right triangles. And if you look at this first example here, it's a pretty good example that kind of shows us a little bit what we're going to be doing in this section. It says use the trig ratio cosine A is equal to 0.6 to determine which angle of the triangle is angle A. And so if you look at the ratio here, we have cosine of angle A is equal to 0.6. So we're wondering which of these two angles would be 0.6, would have that ratio. Of course, we know cosine A is equal to the adjacent leg over the hypotenuse. So what we are doing here is taking cosine of angle 1, and if you take the adjacent side, 3.6, divided by the hypotenuse, 6, we get 0.6. Then if you take cosine of angle 2, the adjacent side is 4.8 divided by the hypotenuse of 6, you get 0.8. And so comparing those two, we find that angle 1 actually is equal to angle A. In other words, we get 0.6 here and 0.6 there, so we know that angle A, or A, the angle measurement of A, is going to equal this angle 1 here. And that kind of leads us into these inverse trig functions. These are pretty good things to know here. We have our basic trig functions here, sine, cosine, tangent. We've talked about those. And each of those, as you take the angle, will give you a ratio which we'll call x. Now the inverse trig functions actually kind of work in reverse. And they're indicated with a little -1 here. And what we're doing is we're taking the trig function, the inverse trig function of the ratio x, and what we're getting out actually is the angle. And these are buttons that are actually on your calculator. And if you look here, you can punch these in, and when you plug in the inverse cosine of 0.5, for example, you get out 60. That means that the angle would be 60 degrees for this ratio of 0.5. And same thing here, these are all giving us angles out. And so when we want to solve right triangles, this is kind of nice to help us find angles. In this example here, we have our right triangle, and we know a couple of sides. What we'd like to know are the angles. First thing that we do here is use the Pythagorean theorem to actually find our hypotenuse, which is 9.01, it looks like, if we take the square root of 81.25. And if we use the inverse of tangent, tangent again is our angle A is our opposite over adjacent, and you plug this into your graphing calculator or scientific calculator, you're going to get 34 degrees, so that would be angle A. You could do the same thing for angle C, or the easier way probably is to take 90, because these two have to equal 90. Take those two, subtract 34, and you'll get 56 degrees. There is a method too here as well, and you can read through that as well. And then this example here is just showing us kind of using coordinates and plotting these points. Again, we were able to solve this by counting out the units, using the distance formula again to find the hypotenuse, and then we can make our measurements of our angles using the inverse of tangent again as well. There are lots of good application problems for this as well as you go through. And again, if you have any questions, please let me know. Thanks.